Your understanding on page 400. The first question is we want to find mu sub x, which is the mean or expected value of this distribution. The formula is on the formula sheet as n times p, and n was 10 because there were 10 questions on this quiz, and p was 0.2 because that's the probability of getting a question correct. That is 2, and that means if many students took this quiz, we would expect them to get 2 questions correct on average. Number 2 is sigma sub x, which is the standard deviation of this distribution. That's also on the formula sheet. So we just plug n and p in, and we get 1.265. That means if many students took the quiz, we would expect each student's score to vary from the mean of 2 correct answers by about 1.265. And then number 3, what's the probability that the number of Patty's correct guesses is more than 2 standard deviations above the mean? So the number that she gets correct needs to be at least 2 standard deviations above the mean. So the mean was 2. 2 standard deviations above the mean is 2 plus 2 times the standard deviation of 1.265. That comes out to 4.53. So 4.53 is 2 standard deviations above the mean. But she can't get that number correct. It needs to be at least that much, so 5 is what we're looking for. We're going to round that up to 5. So we're basically trying to find the probability that she gets at least 5 correct. So I'm going to write it like this. We're going to do the complement of that, because in the calculator, if we go to binomial CDF and put in 5, that's actually going to be everything up to 5. The calculator just does everything up to that number. So we're going to do 4 instead. We're going to do the complement. So we're going to do 4 into binomial CDF. Put a second distribution, binomial CDF. 10 questions correct, 0.2 was the probability, and then we're going to put 4 here. So this will give us that probability that she gets 0 or 1 or 2 or 3 or 4 correct. So there's about a 96.7% chance she gets 0 or 1 or 2 or 3 or 4 questions correct. We want 5 or more. So we're going to do 1 minus that number, and we get about 0.0328, which is our answer. So there's about a 3.28% chance that Patty will score more than 2 standard deviations above the mean.